Some questions I had actually picked for today's review class. So maybe we will just look into them. Okay. This is, if you are able to see the screen.
Yes. Yes, ma'am.
Yeah. So, which graph shows zero activation energy? What is the importance of activation energy?
The
Reaction to
additional
you.
energy required by the reacting molecules to
You raise to product.
Yeah.
reaction.
So, which which of the following is? In fact, I actually cut off two diagrams here, two pictures here. So they were literally not. No, they would confuse. Yeah. So there are two options given there. Which of the graph shows zero activation energy? Which one will be possible? Like which one will be suiting this question? Which graph will show zero activation energy?
I think second one, I think, ma'am. The first
Hmm.
one.
In the case of first one, the reactance energy is
More.
Less than
less
the
than. So normally the graph looks like this, right? Reactants turning into products, energy of the reactants, activated complex, and then have the
Yes, ma'am.
so energy of the energy of the activated complex, right? Would be definitely, let us put it not as this one, let us put it as energy of the activated complex will be always more than the energy of the products. So in this case, it looks like this is energy of the reactants. This is energy of the activated complex. And this looks like energy of the products. So it is not possible. Whereas here in this case, it looks like this is energy of the reactants. And in this point
Energy
is
of the
energy
product.
so there was no peak.
Yes.
And when we define the activation energy, we say that the difference between the average energy of the molecules and the activated complex will be called as the activation energy. So this difference is missing. So in such cases, the activation energy here is zero. Is it okay?
Yes, ma'am.
So energy of the reactants probably has to be lesser than energy of the activated complex, which has to be greater than energy of the products. This is how the relationship goes. So
Yes.
this actually there were two more two more projections given. As you can see, this is A and C. Option B was energy versus the state of reaction. The graph was given like this, and there was another option wherein it was varying like this. So even those will not be possible. Okay. Though energy of the activation is zero here also, but the reaction never proceeds this way, it seems. So it is going to be this answer. Can the activation energy be zero? Can the EA be zero? Can EA be zero? Is it possible for us to have reactions with zero activation energy?
No, ma'am.
Not possible. What would be missing then? Why not possible then? Why not possible, ma'am?
After gaining that minimum energy only, the reaction will occur.
Yeah. After gaining that, or if there is no energy barrier,
To cross.
won't the reactants automatically be in the form of product? Won't the reactants automatically be found as stable products, ma'am?
That can also be possible now.
Say, for example, I've got a water tank and I've got a tap here. What if the tap is kept open? The tap
automatically the water will flow.
Automatically the water will flow. So there is no barriers to stop. Supposing this water tank is No, having a tap closed, then the water stays inside.
Yes.
And if this is opened out, obviously the water will flow out. So something like that, no, the reactants have to get some amount of energy to, otherwise see, energy of the reactant is here, and traditionally we plot this diagram where energy of the product. Now energy of the product is less, no, it is highly exothermic, it is less than in this case. So straight away the transition could have occurred.
Yes.
So activation energy is the one which keeps the reactants as reactants, unless we provide some special circumstances, maybe a nucleophile, an electrophile, or an hydrolyzing agent, or temperature or pressure, physical or chemical conditions. The reactants become unstable. After becoming unstable, they tend to form better bonds, stabler bonds. So reaction can never have a zero activation energy. Otherwise, it doesn't make sense. Otherwise, it means all the reactants are already products.
Yes.
Okay. What will be the order and molecularity of this reaction?
Total number of reactants reacting in a reaction is called as molecularity, ma'am.
Okay.
Number
So
of
the number of entities that take part in the
chemical
rate determining step, which undergoes simultaneous collision. When we like award marks for this question in the board, we normally pay attention to all these words, sir. The number of molecules undergoing simultaneous collisions. So these words are important. So in this case, what will be the answer?
2. Number of reactants 2.
Okay. Is information lacking here to find out the unit of K? Order? Is there anything wrong with this? Okay, if I give you another reaction like N2 plus 3H2 is giving 2 NH3. And there is a catalyst. Iron molybdenum catalyst. There is a promoter, K2O, aluminium oxide, etc. So what will be the answer for this particular case?
Number of reacting species 4.
Okay. Now, okay, there are some general understandings that we must carry.
Yes,
The
ma'am.
reactions which are photochemical, the reactions which are heterogeneously catalyzed. These reactions are basically zero order reactions. Like how we say, no, that radioactive disintegration is always first order. Likewise, we have to carry the information that the photochemical reactions are zero order. Similarly, heterogeneously catalyzed reactions are also zero order reactions. So now can you give me some more details, some answer? What will be the order in this case? It's a photolytic reaction, right? Photochemical reaction.
Zero order.
So it must be zero order. Same is the case with this.
Yes, yes.
Catalytic reaction. So these understandings we must give to the children that when the reaction is a photochemical reaction or if it is a heterogeneously catalyzed reaction,
It should be zero order.
Zero order. So molecularity. For this, it looks like it is 1 plus 1. So molecularity can be 2. But what about this case? Can we say it is it's molecule? See, I told you, no, that the order and the molecularity values are same, right? When it is the rate determining step.
Yes.
When you have picked up the right rate determining step, we say that order is the molecularity. So here the order is 0. Order is 0. So do you think that 4 entities can undergo simultaneous collision according to the definition of molecularity?
No.
No way. What is the
Mm.
maximum possible value? The maximum possible value would be
1, 2.
3. So when the number of molecules here interacting to form the products are 4, then the molecularity for this reaction cannot be 4, but we don't
Yes.
know.
Yes.
We don't know what it is. Unless the mechanism is given to us, we will
We
not
can-
be able to predict. But here it looks obvious that at least hydrogen and chlorine should interact to form HCl.
Mm.
So at any point of time, the older bonds in H2 and Cl2 must be broken and newer bonds must be created. So it must be 2. So if we have concluded that it is a zero order reaction, then what should be the unit of K then? Normally we say rate law is K into concentration of the reactants to some power. What is the value of X in this case?
0.
0. So A to the power 0 would become equal to K. Am I
K.
right?
Yes, ma'am.
So what is rates unit?
Mole inverse.
Okay, how do you define rate? In the beginning of the sessions, we said it is rate of
Range. Range of concentration in reactant or product divided by time.
divided by time. So
Hmm.
concentration change of the reactant, change in the concentration by time. So this is concentration term. So it is molarity or moles per liter. And this is time. So it must be per second or per hour or per minute or whatever it is. So moles per liter per second. So whether it is a zero order reaction, first order reaction, second order reaction, the unit of rate will never change. Because rate, how do you define rate? Whether it is a zero order, first order, second order, third order, or whatever order it is, the rate is defined as change in the concentration of the reactant per time.
Per time.
So it must always be moles per liter per second or per minute per hour, depends upon, because we are not working on SI units, so no compulsion. Depends upon the time period the reaction consumed. So rate is expressed in terms of capital M per second or mole per liter per second. So what would be the unit of K? Same as the rate.
Yes.
Did you get the point?
Yes, ma'am. Yes, ma'am.
So the things which we have to communicate to children is that photochemical reactions like silver
And
chloride,
Mm.
yeah, AgCl in the
Silver
presence of,
bromide.
yeah, Ag plus Cl2, half a mole of Cl2. So
Yes.
these reactions wherein light is the source of energy, and catalytic reactions, heterogeneously catalyzed reactions.
Only heterogeneous catalyst, ma'am.
Yes, generally heterogeneously catalyzed reactions depend upon the catalysts.
Oh.
So how do you plot, like, no, when we say that it is rate versus concentration, what do you say? It is constant. So no matter what change in the concentration, how much ever increase in the concentration is done, the rate is going to be constant. So it is a zero order reaction.
Yes.
Is not affected by change in the concentration of the reactant. So the catalyst is heterogeneously catalyzed reactions and photochemical reactions. For them, the order of the
Order
reaction
is 0.
So molecularity, a sensible answer we can always give. Another question which normally we discuss, we give as thoughts is this question. We say no, ester C2H5COOCH3 in the presence of water is giving C2H5COOH plus CH3OH. This is also catalyzed by an acid.
Mm.
So what is the peculiarity of this reaction? In what context do we take this example?
Pseudo first order.
Pseudo first order reaction, ma'am.
Pseudo first order reaction. So in pseudo first order reaction, again they will ask the question, what is order, what is molecularity?
Molecularity is 2, but order is
Order is 1.
Order is 1. What should have been a bimolecular reaction is acting as a Unimolecular.
Yes.
Okay, so the similar question, what is order molecularity? Right, they can, there are questions of this sort possible. Okay, look at this question, check whether this is 1/3. The rate of reaction involving gaseous reactant increases by 27 times when the volume of the reaction vessel is compressed to 1/3 of the original volume. Find the order of the reaction. What can be done? Let me, if you are not getting the clue, supposing I have a gas, A. Now the rate is going to depend on the A to the power X, right? Now the same thing, we are putting up maybe a piston here and pressurizing and bringing down the volume to 1/3 of the original. So the piston is here. And this decrease by volume to 1/3 of the original is increasing the rate by 27 times. So what should have happened to the concentration?
Concentration will not change.
Will amount remains the same, but concentration will change, ma'am?
Increased, ma'am. Concentration increased. That's
Yeah.
why the rate increased, ma'am.
Yeah, so the
Amount will not change.
concentration, what gas was spread across this volume is now compressed to 1/3 of the original volume. So don't you think if the molecules were far off here, the molecules are close enough now to interact?
Yes.
So the concentration has increased, number of moles per unit
Per
volume.
volume increases.
So this increase is by what? 1/3, no? So when I say that the volume of the vessel has dropped to 1/3, the concentration would have got increased by 3 times. Did you get it, ma'am?
Yes, ma'am. Yes. Yes.
Okay. So it was as though, let us say 10 students standing in this region, and now the same 10 are here. So here they are spread across a larger volume, and here they are concentrated in a small space.
Small. Yes.
Obviously, concentration is more, right?
Yes.
Because you find more number of reactants per unit volume.
Yes, ma'am.
So concentration increased since the supposing the vessel was allowed to expand, then what would have happened?
Concentration decreases.
Decrease. So say this is 1 volume, 2 volume, and 3. So I'm removing these barriers, and I'm now expanding this gas by releasing the pressure to a volume which is 3 times. So when the volume becomes 3 times for this gas, the concentration will decrease by
1/3 times.
3 times. So here it is an increase in the concentration, and hence it is compressed to 1/3 of its original volume. So concentration has increased to 3 times. So if this is 3, if I put the 3 here, and the rate is becoming how many times? Rate is becoming
1/3 times.
No, rate has become, the rate of reaction increases by
9, ma'am.
So originally it was, let us say, a to the power x. Now by compressing, I am increasing the concentration by 3 times. And the rate is now becoming 27 times. So what should have been the value of x here?
3, ma'am. 3.
Yeah, if x is equal to 3, then it would be 3 into 3 into 3. 3 to the power 3 equal to 27.
27.
Yeah, this was one of the rare questions which we had earlier. Yes, yes.
Yes, ma'am. Yes.
Then this is one MCQ which I found interesting. I think there was one question of this sort earlier in some 3-4 years back. For a reversible reaction, where the forward reaction is exothermic, where the forward reaction is. So let us say reactant is becoming product and some heat is given out. It is exothermic. Which of the following statements is correct? So if it is an exothermic reaction, at a glance, the statements look little confusing. So instead, if you can plot the energy diagram, it will help. Energy of the reactant, energy of the product. Since it is an exothermic work, the energy of the product must be less than. So can we put the graph like this? Energy of the reactants, energy of the product. Now, if you read the statements, the backward reaction has higher activation energy than the forward. Is it true?
Yes, ma'am.
Yeah. So this difference is the
Is
energy
less.
of activation for the forward direction. And this difference,
Energy
will
for
be
the backward
energy of activation for the backward reaction.
reaction.
So backward
Which is
reaction is higher.
More.
So this is right. Any other statement is right?
Backward and forward reaction. Same activation energy, wrong, ma'am.
Wrong. So the energy diagram should look like this.
Hmm.
Why would the reaction happen? So not possible. The backward reaction is lower activation energy, which just now we concluded not possible. So no activation energy is required. No way, no?
No way.
If the products have to form the reactants again, then they also have to cross the energy barrier.
Yes, ma'am.
So
So
no
that's correct.
activation energy is required is wrong.
1 minute.
Yeah, the next one. I think it's only the statements which are confusing. Otherwise, it's a very simple, straightforward question. 2A gives B plus C would be a zero order reaction when? What would be the option? Zero order. The rate of reaction is proportional to square of concentration. Let us try writing. Rate is proportional to square of the concentration of the reactants. Correct? Huh?
Yes, ma'am.
Okay, this is the translation of the statement. But what is the declaration given?
Which is not correct, ma'am. This is a second order reaction.
Yeah. So what about this one?
Second one is correct, I think, ma'am. The rate of reaction.
There is rate of the reaction same at any concentration of A. So it does not depends upon the concentration of E.
Yes. Whatever increase in the concentration or decrease in the concentration is done, the rate value remains the same. The rate remains unchanged at any concentration of B and C. What is wrong in this?
So if we increase the concentration of A or decrease the B and C will be same. Am I right?
Which is correct, but the B and C are the products, ma'am. We are not bothered about the concentration of the products. That's
Correct.
why this statement is not required, ma'am.
The rate is proportional to only the reactants concentration and not the products. So B and C according to this equation. So same is the case with this. Concentration of B is increased due to double. Let it be, but the rate is unaffected by the presence of increase or decrease in the concentration of products. Okay, so this one, right. I thought we'll have a recap. And what were the other questions that I had collected? Maybe because you are saying chemical kinetics, children find it difficult. Yeah. So this is similar question, no, sir? The reaction is of second order with respect to a reactant. How will the rate of reaction be affected if the concentration of this reaction
is doubled? or reduced.
to half. So what we normally do is rate is proportional to or rate is equal to, let us say, K into the reactant to the power 2. This is the original. So what is the new rate? The rate which is now because of this will be what? Will be K into the concentration of the reactant is doubled. So it
2A
is
power 2.
the power 2, which is, so this is, let us put it as new. If you write like this, it will be very clear.
Yes, ma'am.
Become 4 times K into A to the power 2. Now, what is this? This is this not the old rate? 4 times the rate 1. Shall I put it as 1 and 2? By old new. So this is 4 times. So the
Rate 1.
rate 2 is 4 times the rate 1. Yes.
Yes.
Sometimes the children, no, they don't get convinced so easily. Reduced to half. So we start by writing rate 1 is equal to K A to the power 2. And then we try to figure out what is rate 2 by doing the change on the reactant. Is reduced to half. So it is 1 by 2 of A, which is 1 by 4 times K A to the power 2. This is already equal to rate 1. So rate 2 is equal to 1 by 4 times
Rate 1.
yes. Can we proceed? Look at this.
Yes, ma'am. Yes, yes, yes.
The thermal decomposition of the given compound methanoic acid is a first order reaction with rate constant 2.4 into 10 to the power minus 3 per second at a certain temperature. Calculate how long will it take for 3/4. I told you, no, children sometimes go wrong in this. How long will it take for 3/4 of the initial quantity to decompose? Ask the children to read this again and again. I do that actually in the class. I tell them, read 2-3 times. Only then you will grasp. How long will it take for 3/4 of the initial quantity to decompose? So now they will say 3/4 has decomposed. So what is left out?
1 by 4.
Yeah. So it is 1 by 4. So if we had started with 1, so if I say A naught is 1, then A at a given time, amount of reactant left out at given time is 1 by 4th of the starting material. If I say this is 100, because they follow so many books, they might see so many expressions. They might have seen 1 becoming 1 by 4 or 100 becoming 100 by 4 or 6 by 4. All these mean the same. So rate constant is given and how long is the question. Look at the unit of the rate constant. It is given in per second. So it is T is equal to 2.303 by K log of the concentration initial by concentration at time T. So this is going to be 2.303 by 2.4 into 10 to the power minus 3 per second. If they write the unit, better, because finally their answer will be in seconds. So that way they won't make mistakes. Log of 1 by 1 by 4 or 100 by 100 by 4 or x by x by 4. Anyway, it is going to give you the same answer. So the calculated value, and tell the children that log values will be provided in all circumstances. Yeah. So in that case, they need not worry, and sometimes even they can take hint from the log value. Why have they given that log value also? Can no maybe give us some hint to the children as to how to proceed with the question. Yes, so this, as I told you, this is often a confused term. What is AT? Sometimes they write the left out, sometimes they write the consumed amount. Children normally will say, the moment they say 3/4, they will put it as 3 by 4.
Yes.
This is one of the common mistakes. So if you keep defining AT, it will not happen. If you keep defining that AT, it won't. Rate constant, I think the similar.
Same, similar.
I think 3/4 or something was the case. Yeah, 3/4 life. 3/4 life. Rate constant is given. Calculate the 3/4 life. What do you mean by that? 3/4 life.
83/4, ma'am.
3/4 life. Sindhu ma'am.
Final 75%, no?
Final. Calculate.
75% consume, 75%.
Consume.
So that's the
3/4
difference
life.
between the two
Suppose-
questions here. They should interpret it rightly, as you did.
Supposing, yeah, an organism is living for 100 years. What is its 3/4 life?
75.
75. So 75 is over. Isn't it? 3/4 is over, and hence 25 is pending. Can we make them clear with this?
Yes, ma'am.
Say a tortoise is living for 100 years. What will be its 3/4 life? It would be already 75 years old. So take that. I think others are, other thing is similar. Okay, this was the question. Calculate the rate. This one you were saying, no, ma'am?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
Yeah. So this is involving the decomposition of azoisopropane to hexane and nitrogen. So this is our textual question. Okay. Actually, what I wanted to do some more of this content. That this, let us assume azoisopropane is A, hexane is B, and nitrogen is C. So let us put it as A is becoming B plus C. And incidentally, they have not furnished enough information. Child is supposed to know that all these substances are gaseous in nature. The question is not giving so much, but a hint is given that only the pressure initial is given. So pressure can be only for a gas, cannot be for a liquid or cannot be for a solid.
Equation is also not given here, no? That 1 mole is giving 1 mole each of products also.
So it is more like we solve NCERT question and then only we conclude that it is. Yeah, by looking at the answer only we have concluded this also. So at T is equal to 0, whenever you write even in chemical equilibrium cases, you ask the child at T is equal to 0, what is the amount? At T is equal to 0, the amount is A naught. And this A naught is how much? It is expressed in terms of at T is equal to 0, the pressure is 35. So it is 35 mm of Hg. Sorry, 35. It is 35. So after some time passed, some amount of time has gone. What would happen? There would be some decrease in the amount of reactant, and parallelly, since the number of moles is 1:1:1, X moles of B and X moles of C also will be formed. So since all these are gaseous, this exerts pressure, and this also exerts pressure. So the P total will be, because of the left out A, newly formed B and newly formed C. So the amount of A left out is A naught minus X. The amount of A left out, the reactant A left out was, how much was the initial? A naught. From A naught, how much got reacted? X. What is the amount of reactant left out?
A naught minus X.
So amount of A left out is A naught minus X. What is the amount of B which is formed? Amount of B which is newly formed is
50.
X. X.
X is okay.
Yeah.
We have
And
to consider
amount
that.
of, yeah. So if it is something like from the given initial amount of A, if X has reacted, since it is 1:1:1 mole and the temperature and the pressure remains, the outside pressure remains constant, let us say. So in that case, if there is a decrease for A, there will be an equal amount of increase in terms of
B and C.
Had it been 2 here, what I would have written? I would have written 2x.
Yes.
So that's how the questions may get varied later on. You may have more number of products. So it is A minus X, X and X. So the amount of reactant left out is A naught minus X. The amount of pressure created by the newly formed B is X.
Yes.
The amount of pressure created by the newly formed C is X again.
Yes.
So this now becomes A naught plus X.
Plus X.
Yes. Now
Yes,
what
ma'am.
was A naught? A naught is nothing but P initial. A naught is nothing but P initial. So can we put it as P initial plus X is equal to P total? What was A naught? A naught was the initial amount of reactant, and that created the pressure all alone, which is now equal to Pi. So A naught is Pi. So what is the value of X? It is P total minus Pi.
Mm.
Now, since, okay, now the question is, see, we at the end of this question, we would have already come to the conclusion that it is a first order reaction. But there is a catch in that also. Earlier, I remember in the old textbooks, we had questions to prove that it is a first order reaction. Now we don't have those questions. So since it is, as I said, it is now concluded by all of us that it is a first order reaction. It is 2.303 by T log of the A naught by AT. What was the definition given for AT? The amount of reactant
At time.
left out at time T. Left out at time T. So what is the expression indicating A naught? What is the expression indicating A naught? The
PA.
Pi. So let us substitute Pi. So 2.303 by T log of A naught is nothing but Pi by what is AT's definition? The amount of reactant left out at time T. So I started with A naught. Now how much of reactant do I have? I started with A naught. How much of reactant is left with me? Reactant alone. I started with A naught. Let us clear out all this.
Yes.
I started with A naught. At the time T, how much of reactant is left out?
A naught minus X.
A naught minus X. So let us put A naught minus X. What is the value of X?
P total minus PI.
So 2.303 by, at what time are we considering this? When the P total has become 54. What was the time? And yeah, so I want to take this P total. When was that? It was at 360 seconds. So log of Pi is nothing but 35 by A naught minus X. What is X? P total minus Pi. What is A naught? A naught is nothing but Pi. So don't we get this expression? 2 Pi minus P total. It is because of
Yes,
this
yes.
substitution only.
Yes, yes, yes.
Yes. So teach them this calculation. As sir was saying, in equilibrium, we do a lot of this work. So if they are comfortable with this, in equilibrium lesson, they will be able to do well. Supposing I had 2 moles of C here, how will the expression change? This would become 2x.
2x.
And here I would have to write the left out
Plus
reactant plus X
Plus 2x.
2x. So
Upper
this
A naught plus 2x will be.
2x. So X now will become P total minus Pi by
2.
And when you substitute, it gives you a different denominator. That's all. So this is how, there are 2 questions in our textbook. One is in the solved example and the other one is in the exercise. I think there is one SO2 Cl2 question in the text where I think there is a variation, if I'm right. So you...
For this one, since the order is not mentioned, don't we go for 2 trials?
That's what.
No? 0, 3,
yes.
and any other.
So that's what I was saying. In the older textbook, we used to have this as a task. Prove that it is a first order reaction. So you would get some value of K. And we know that K changes with change in temperature only, not with the change in concentration. So even when you do it for a reaction going up to 720 seconds, you keep repeating the work. How to repeat? Let us put it here. What was the expression? 2 times Pi minus P total. So for this substitution, what is Pi value? It is 35. This is going to be 35. 2 into 35.
35.
Minus P total, how much? 54. And when you are doing the same calculation for 720 seconds, the expression will look like 2.303 by 720 log of Pi by 2 times Pi 35 minus the new PT. What is new PT?
63.
This value of K, if it matches with this value of K, then only you can conclude that it is a first order reaction.
Order reaction.
Okay, so
Yes.
at least 2 times has to be done, because at least you prove that K is not changing with change in concentration. Yes, teachers, so keep deriving this. Do not ask them to memorize this.
Yes,
2P
ma'am.
minus P total is temporary. It may change depending upon the change in the number of products. So this expression, this question is maybe a continuation of that only. The following data was obtained during first order. Now in the question, see the previous question, they never said it is a first order reaction.
First order reaction.
Whereas here they are saying the similar question, it is same question. So let me just take it. And so the question, if you see, in contrast, here it says the following data were obtained during first order thermal decomposition. Whereas here, the previous question never said it is a first order reaction. So you were to give an attempt with the zero order, then first order. And since by attempting 2 times in first order reaction, the K value is same, it is declared to be a first order reaction.
First order.
So this is actually, I think, 20th or 21st question, I'm not sure. And the next question is this in your textbook. So let us leave this. Let us go to our present question. So in this question, what happens now? Again, you can see that it is gaseous. Yeah. So it is 1 mole, 1 mole, and 1 mole.
1 mole.
Yeah. And this is, what do you call this now? Can we say this is initial concentration of the reactant? And also, can we say that this is P initial?
Yes.
What is this? 0.6. This must be P total. This must be P total. Why P total? Because SO2 Cl2 would have broken down into, so at T is equal to 0, if you had A0, the amount of SO2 and Cl2 were nothing.
0.
But if A0 lerundu, if you take away X,
X, this side.
X and X. So P total is a sum of A0 minus X plus X plus X, which is A0 plus X.
Yes.
So it is Pi plus X. And since it is Pi plus X, the P total seems to be more. Seems to be more. Okay.
Yes,
So
ma'am.
it is declared that it is a first order reaction. So we need not worry about it. Now the question is, calculate the rate of reaction when the total pressure has gone up to 0.65. But the time is not given. Not required. Okay, leave it. So that means that initially we started at 0 seconds, then we went up to 100 seconds and analyzed. Maybe some more time passed. We don't know how much it is. Let us not worry. So at this time, definitely the amount of reactant would have come down, no? Furthermore. And we know that the rate is proportional to the concentration of the reactant. More the concentration of the reactant, more the rate.
First order.
Yeah, progressively, any order, any reaction, excepting for the zero order reaction,
Okay.
as the reactants get consumed, so the rate must drop down. So rate was high in the initial stages when there was only reactant. The rate is slightly less because some reactant is already consumed out. The rate will be further down because some more reactant got consumed. So the rate is definitely down because of the decrease in the concentration. The rate has decreased. So decreased value, or we can say the amount of reactant left out at a new time 3. In the serial number 3, at a new time, the reactant is further down. So what is this? The rate is now dependent on the amount of reactant left out at this time. What is the definition of amount of reactant left out? It is 2pi minus P total in the scenario where it is 1:1:1. 1 mole is giving 2 moles of products. So the rate is dependent on K into left out concentration of A or AT. AT is nothing but 2pi minus P total. So now you have P initial. It is not going to change. What is the P total now for which we are asking you to calculate the rate? We are asking you to calculate the rate when the total pressure has
0.65.
Yeah, 0.65. Now don't limit the question to this. Ask them to calculate it for 0.68 also. 0.70. Sometimes anyway it will go wrong because maybe the reactant has got completely consumed, all that. This whole thing may become negative. That is also there, but at least close by value 0.67, 0.68, 0.69, so that they realize, they understand the process, the whole process. Yes, sir. Is it okay, ma'am?
Yes, ma'am. Yes, ma'am.
This is another question which is frequently asked in the board examination. It's a NCERT question only. Similar question with respect to phosphine. I think we had one question. One big paragraph question used to be there in chemical kinetics. So what fraction of the sample of sucrose remains after 8 hours? What fraction of the sample of sucrose? Sucrose decomposes in acid solution into glucose and fructose according to the first order kinetics, with T half is equal to 3 hours. So if you know the T half as 3 hours, then you know the K value, 0.693 by T half. So you know the K. What fraction of the sample of sucrose remains after 8 hours? What shall we do? Supposing in your class you have 40 students and some students went out to play. 30 students went out to play. What fraction of the students are left out in the class? How many students?
1/4.
Okay, 1/4. What number of students are left out in your class?
10.
10. 10 by 40 will tell me the fraction of students left out in the class.
Yes, ma'am.
You get it? So 40 became 10. So can we call this 40 as A0 and 10 as AT? And can we say 10 by 40 is the fraction of students left out in your class? So is it not 80 by A0 that you are supposed to calculate? What are you supposed to calculate? Children will be confused only with that. What fraction of the sample of sucrose remains after 8 hours? What are we supposed to calculate? Like, they know the English meaning of the statement, but expression la what to look for. So in terms of expression, they are asked to calculate 80 by A0. Make this very, very clear to children. What fraction of the sample remains? What fraction of the sample has reacted?
30 by 40.
That's all. 30 by 40. Yes. So it is A0 minus 80 by A0. In fact, it is this. A0 minus 80 by A0. 80 by A0 is fraction of the sample left out. Fraction of the sample which has reacted is A0 minus 80 by A0. So this is what we are calculating. So now it is a usual problem. So k is equal to 2.303 by k, that is t log of a naught by at. And we must keep in mind that what fraction of the students, what fraction of the sample is left out is 80 by a naught. So from this, we are supposed to isolate a naught by 80, invert it, whatever you do, introduce a negative sign, whatever you do, but you are supposed to calculate this. So k is equal to 0.693 by t half is 3 hours is equal to 2.303. You are asked to calculate it at 8 hours. Normally, there is one another confusion they create. Sometimes they would give t half in seconds and they may ask in hours or in minutes and seconds. So that way they may start creating confusion. There was one question we remember where t half k value is mentioned in seconds, and even in our textbook there is one question where there is minutes and second mixed up. So tell the children that they have to be uniform with the time. It can be in seconds, hours. If they are given in hours, let them not complicate it by multiplying it with 60, 60 and all to make it into second and all. Nothing required. If it is hours, keep the other one hours. If it is decade also, you keep the other one as decade. So it should be as far as possible the largest unit of time, better, so that the kind of calculations are not complicated. So log of a naught by 80. So now you can isolate this, right? If you are going to invert this, if I put a negative sign here, can I write it as 80 by a naught?
Yes, ma'am.
80 by a naught. And now isolate all of this. So it is going to be minus 0.693 into 8 by 3 into 2.303 will be log of at by a naught. And now there is no difficulty. If you keep solving this, they would have given the anti-log value. They would have given the anti-log. In the question paper, they would have given the anti-log value of this value. So it is as simple as you want to cancel the log here, take anti-log. If you're taking anti-log, log and anti-log get cancelled, you will be left out with 80 by a naught. If you're taking anti-log here, you must also take anti-log here, as simple as that. So anti-log of this value will be anti-log of log 80 by a naught. Log anti-log get cancelled. Once this is cancelled, you will be left out with the value of 80 by a naught. So normally, what are they supposed to care? In terms of the formula, what are they supposed to find out? Is the question in their mind. So while teaching your questions in the textbook, keep telling them this is what is required. Then what are the questions expected here? Graphically, what we have is like plain questions will be, they will be giving you the graph. Sometimes we have had some questions like this, and they will be asking you to find out the order of the reaction. So it's always better to look at the X and Y axis and decide. And then they might give the value of slope. Okay, one another thing is, if they are, this is for a first order reaction. This one is, okay, let me take this expression. This is, what is the other form of it? Is it not 2.303 log of A is equal to minus KT plus 2.303 log of A naught? Yes. So you can either write it as T is equal to 1 by K ln A naught by AT, or you can put it as T is equal to 2.303 by K log of A naught by 8. So the difference between ln and log is the 2.303. So tell them clearly that if it is ln, let them forget about 2.303. Even by mistake also. This is also true in Arrhenius equation questions. If the expression is with the ln, log to the base e is indicated as ln. Log to the base 10 is plainly indicated as log. If the expression is in ln, let them forget, never take 2.303. But if the expression is with log, they have to consider the 2.303 factor. They go wrong only in that. They go wrong only in that. So sometimes they would give you the slope value, both in Arrhenius equation as well as in this. They may give you the slope value. They may ask you the rate constant. So identifying the slope's significance and equating it to the K or K by 2.30. Either it is this or that. So if it is ln, no 2.303. If it is log, 2.303 must be there. This one. Yeah, I think this we discussed. Okay, this is one another question. This is one example question. And once we had it in the board, only one year we had this out of all these years. The activation energy for the reaction 2 Hi giving H2 and I2 is 209.5 kilojoules per mole. As and when they read the question, let them mark these kilojoules, because later on they are going to use the term R. And if they are going to use the term R, then R is 8.314 joule per Kelvin per mole. And if it is this SI units, this is in joules, this also should be in joules. So when they read the question, wherever they see the kilojoules, particularly in activation energy problems, if they say kilojoules, Gibbs free energy problems, if they see kilojoules, let them put a circle around it, keep it ready to be converted. So kilojoules per mole at 581 Kelvin. Calculate the fraction of molecules of reactants having energy equal to, so again they should not go wrong with the fraction. This is not the same fraction. Fraction of molecules left out is different from fraction of reactants having energy equal to or greater than the activation energy. So when you teach the Arrhenius equation, K is equal to A e to the power minus EA by RT, tell them, we all do that, this term is the fraction having energy equal to or greater than activation energy. Any problem in proceeding with this problem, teachers? Any problem in proceeding? Calculation, sometimes children feel it is, unless they have understood, they know better maths than we know, so they will do. But sometimes if they find it difficult, then it is for us to help. So we are.
Can I ask one question, ma'am?
Yes, sir. Yes, sir.
What is the difference between ln and log, ma'am? Generally, we are using logarithm table, then we find the values for particular log value, ma'am.
Sir, actually,
but ln also kinetics coming, ma'am. That's why
that's what,
they're
sir.
asking the conversion from ln to log. But yes, ma'am.
See, the some 2 years back, I think we were teaching log also. Only since last 2-3 years, they have told that log tables will not be given, and log values will be given in the question paper. Which basic thing is that logs can be expressed to the base e to the base 10, sir.
Yes, ma'am.
The base 10. So it's something like if I take log of 1, what is the answer, sir? What is log of 1? Or if I take log of 10, what will be the answer?
1, ma'am.
Log of 10 is 1. Yes, sir. So
yes, sir.
Log of 10 to the base 10 is 1. It means log of 10 to the base 10 is 1.
Yes,
or in other words, what power of this 10 will give me this answer. So 10 to the power 1 is 10. That's how the maths goes. But anyway, we need not worry about that. See, if we start teaching maths, which is not our domain, we will confuse the children only. So what we can tell them is log values are available for 2 base systems. One is to the base e, the other one is to the base 10. Right? Log, we mean to say log 10, log to the base 10. And when ln is indicated, its base is not 10, its base is E. Do you get it, sir? Whenever they see
What is it?
ln,
What is the purpose of E there, ma'am? E means what, ma'am? E means
same thing, sir. E log of E to the base E is equal to 1.
oh,
So this is mathematical part. So it is the log systems parallelly, the log values parallelly exist for the base E and for the base 10.
10.
So for chemistry people, whenever they see the term log fully, we will automatically understand that the base is 10.
10.
10.
Whenever they see the term ln, they have to automatically understand that log to the base E is termed as ln. Do you get it, sir?
It may be a number, numerical value
yes,
only.
yes. The conversion
Just like
factor.
XR1 algebra. Yes, ma'am. Yes, ma'am.
So supposing I'm taking ln of some value x. Ln of some value x. Now I have a table which has got log values to the base 10 only. I don't have for log to the base E. So what do? I convert the ln into log.
That's why ln is converting into log.
So when the conversion is done, the conversion factor is 2.30.
2.30.
Yes. Yes, sir. Are we clear?
Yes, ma'am. Okay, ma'am.
Yes. So supposing we have an expression. I think I will not be able to touch upon solutions at this rate. Supposing I say k is equal to a e to the power minus ea by rt. Yes. So what I do is, since there is an e here, exponent here, I would only take ln of k is equal to ln of a minus, it's not minus, let us put it this way. It is plus ln of e to the power minus ea by rt. Sir, what will be log of 10 to the power 2, sir?
0.30.
Log of 2 is 0.3010. Log of 2 is 0.3010. Log of 10 to the power 2 is 2 log 10, no?
2 log 10. 2 into 1, 1. 2 into 1, 2.
This log 10 is anyway 1. So this is 2 into 1, so 2. Similarly, ln of e to the power minus ea by rt is the power itself.
Yes, minus ea by rt.
So ln k is equal to ln a minus
ea
ea
by
by rt. Now, what is the conversion factor of ln to log?
2.303.
Now I have the capability to write ln as log. For chemists, when we want to write the base 10, we will plainly put it as log. When the base is e, we will put it as ln.
Okay, ma'am.
So this will become 2.303 log k is equal to 2.303 log a
minus ea by rt.
ea by rt. So I will put it as log of k is equal to 2.3. Sorry, this also can be. That is, I'm dividing the whole equation by
2.3.
2.303. So this and this will get cancelled. This and this will get cancelled. So I will be left out with log of a minus ea by
2.303 rt.
Now supposing my plot, my graph is this. This is where we said a graphical question can come. So supposing I have ln k as my y. You remember we said any equation when you want to write, please write it as y is equal to m into x plus c. So let us put it as y is equal to, I am putting this as 1 by t. So 1 by t is my x. This is x. So what should be the m? What should be the c?
ea by r.
ea by r
Minus ea.
with a negative sign.
Yes.
And with an intercept on
A.
With an intercept on y-axis. So there is an intercept at the y-axis. The c is the intercept at the y-axis. So how much is it? It's not 0. There is some value. So some value. What is the slope of this line? M is equal to what?
Minus EA by R.
EA by R. So it's a negative quantity, so a downward line.
Hmm.
So what is the slope of this line? The slope of this line is equal to minus
Minus
EA by
EA
R.
by R.
What if I had used this expression? This is my y, 1 by t is my x. There is some slope, there is some intercept.
Hmm. Yeah, slope is equal to minus EA by 2.303 R.
Yeah. So the same line, but only thing it is now slope is equal to minus EA by 2.303 R. So that's what I was saying. When you have ln, by mistake also child should not include 2.303. The ln to log conversion only brings 2.303. So this is one indication. They can check their answers. When they are writing ln terms, 2.303 should not be there. Where it should not be there, they should know the expression. Denominator, numerator, they should know the expression. Got it, sir?
Yes, ma'am.
So when they say log for chemistry, it is log to the base 10. When they want to write log to the base e, they won't say log to the base e and all. They'll put it as ln.
Ln.
Yes, sir? Okay. I think this on the other day we were asking this question. Hope it is okay, clear, no, ma'am?
Yes, ma'am. Yes, ma'am. Yes, ma'am.
I think that's all. So can we quickly go into the solution lesson and see what actually what I had, where is the, like, no, this is just for introduction. We can give some introduction to the lesson by asking them to pick out certain, no, oil packets, milk
And the
packets.
percentage will be there.
Percentage will be there. So they can always, the first part is always about the concentration, and that's very important, not for CBSE's sake. CBSE le hardly any questions on concentrations, but for a competitive examination, they should be completely thorough with their concentration terms. So Henry's law, I'll just scroll through. If you want me to elaborate on any one of these, please tell me.
Yes, ma'am.
Henry's law, the applications of Henry's law, do you want me to discuss? I can just skip.
You can skip, ma'am.
Yeah. Henry's law in respiration is it's the inhalation of the air and leading to the absorption of oxygen into the blood is based on the Henry's law only. The biology teachers will always speak. The partial pressure of the CO2 in the blood is high. Partial pressure of the oxygen in the alveoli is high. Hence an exchange happens. So take those examples. Raoult's law for volatile components. Please tell me where I need to elaborate.
Skip, ma'am. Can move.
What about the graph? Should we do a little bit of this graph?
Yes, ma'am. Yes, ma'am.
Yes. How to explain the graph? So that what I normally do is that I consider that I have only A with me, a component A, liquid A, and a component B pending. So it's kept here. If this is kept closed, then the pressure created by this at equilibrium is called as P naught A. The pressure created by the molecules of B will be now called as P naught of
P not B.
So supposing I mix these two,
Total
I
pressure.
mix these two and keep it closed. At equilibrium, there will be a pressure due to component A, pressure due to component B,
Component B also.
and there will be a P total. P total is PA plus PB.
PB.
And we know according to Raoult's law, PA is equal to P naught of A
Naught A.
into chi A, and PB is equal to P
P
naught
naught
of
A and
into
TXP.
chi B. Okay, so if this container is considered, then what is chi A? Chi A is 1.
Mole fraction.
Is 1. If this container is considered,
Hmm.
chi A is there. So what is chi A? Chi A is 1. Yeah, this is pure A, no? Pure A.
Yes, ma'am.
No amount of B in it. So what is chi A? Chi A is equal to 1. Similarly, in this container, what is chi B?
1
1. So if chi A is 1, that means PA is equal
is
to
equal
P
to
naught
P
of
naught
A.
A
Similarly, PB is equal
is
to
equal
P
to
naught
P
of.
naught B.
Okay, so let us leave these expressions behind. Let us not worry because our botheration is the mixture. So what is PA? PA is P naught of
Not
A,
A,
chi A plus
P naught of B,
chi A.
chi B.
Okay, so what I do is normally I don't introduce the whole graph like this. I do it part by part. So what I tell them is that let me take only component A, chi A is equal to 1. And so here I will represent the mole fraction and here the vapor pressure. So when I have chi A is equal to 1, what is the vapor pressure felt? When the chi A is equal to 1, what is the vapor pressure felt?
P
Won't
naught
it be
A.
P naught A. So P naught A is marked here. So this term is P naught A. Yes. So let me go move ahead, and this is composition, a new composition. Let us say this is 0.1. What is the 0.1's composition? Let us say 0.9 of A and 0.1 of B. The mole fraction. So that means I have added some B to A.
A.
How much B? 0.1.
0.1.
How much A? 0.9.
9.
Okay. So do you think now the P to the pressure due to A will be equal to P naught of A?
No.
No. And we know from Raoult's law that PA is directly proportional to mole fraction of
Yes, A.
in the solution. So if the mole fraction of A has come down, the PA will come down. We know Raoult's law says that the mole fraction of the volatile component is directly
Be
proportional
proportional to the pressure.
So if the chi A has come down from 1, it was 1, it has come down to 0.9. If chi A has come down, the PA will also come down. So what is the new PA? PA is a slightly lower value. Then we go to another composition, composition 2, where it is 0.8, 0.2.
0.2. It
So,
will also come down.
It will also come down. So as I keep doing this, I get a point where the component A is 0. If chi A is 0, what is PA? Chi A is substituted as 0. What will be PA?
It also be 0, no?
Obviously no A, so no contribution of pressure. So hence it meets the x-axis. Now you connect the points and get a straight line. So this is for the component A, how it reacted in the presence of some or more amount of component
B.
Now you tell them that when you put for B, it will look like this.
Opposite.
Again, vapor pressure, B1, and progressively the B is going to decrease.
0.
So now you can integrate these two and you say this is that line. And when the chi B is 1, the pure vapor pressure is P naught of B. What is this composition? This is where from 1 it has come down. B has come down from 1 to probably 0.9. Now B is 0.9 and A is probably
0.1.
0.1. So when compared to its pure state, amount of B in the mixture has reduced. The pressure contribution also reduces. So for it also there will be a dipping points. Now start.
Here XB is 0.
And this will be chi B is equal to 0. But
Yes,
for
yes.
a composition, some pressure is created by component B, some pressure is created by component A. P total is sum of PA plus
PB.
PB. So mathematically, the length of this line plus this line should be the length of the P total. And when I do that, I get this connecting line. So this will now become P total is equal to PA plus
PB.
if you plot the graph and try to explain this is what
Yes, ma'am,
happening,
easy. Yeah, they can understand easily.
so this they understand. Similarly, azeotrope, do the children understand very easily? Azeotrope, what is azeotrope? When you look at P total line, this is the dotted line is when is azeotrope experienced? When the solution is ideal, we don't see azeotrope.
Non-ideal only
Yeah, non-ideal. So either a positive deviation should be there
or negative deviation.
in a positive deviation. Okay, one most important point is in class 11 in equilibrium, you have to explain what is vapor pressure clearly.
Yes, ma'am.
And you have to recollect at this point what is vapor pressure and how it depends on temperature. And how is vapor pressure and boiling point related? These points should be very clearly explained. Vapor pressure to temperature. Vapor pressure is directly proportional to temperature, directly proportional to vapor pressure. Vapor pressure and boiling point are inversely proportional. Very clearly take a number of examples, physical examples, like you keep your acetone bottle open and you can smell acetone, you cannot smell water, which evaporates faster. Acetone evaporates faster because it was vaporizing faster. As it vaporizes faster, you see more vapors putting pressure on the liquid surface, hence more vapor pressure, hence lower boiling point. All that, so much of discussion should be done both in class 11 and those who have missed it out in class 11, class 12 also. So they will understand. So whenever you see this positive deviation graph, this was supposed to be the ideal P total. But after deviation, the P total looks like this, curved line. And at a particular point, the P total is maximum. This is the maximum P total. Corresponding composition is called as azeotrope. Azeotrope is the composition. What is azeotrope? It is a composition.
Mixtures.
Yeah, composition of a particular composition of the mixture A and B, whose vapor pressure is maximum. That mixture whose vapor pressure is maximum. Hence, since vapor pressure is inversely proportional to boiling point, the boiling point is minimum. So you start calling it as minimum boiling azeotrope. Okay, and similarly, in the case of negative deviation,
Maximum boiling azeotrope.
yeah, there will be a point where the vapor pressure total is minimum. At this point, the vapor pressure is higher than the vapor pressure here. At this point, the vapor pressure is higher than this vapor pressure. So this composition will be now called as azeotropic mixture. That mixture which has minimum vapor pressure and hence maximum boiling point, that which boils without change in composition is called as azeotropic mixture. And there is, I thought, I don't know whether it will be useful to you. Sometimes we say no, that distillation is not a solution to separate the mixture showing positive or negative deviation. The mixture
they cannot be separated.
They cannot be separated.
Only at the azeotropic composition.
Yes.
You cannot separate the components.
Yes.
Yeah. So in fact, if you see this, maybe no, I will try to post this. If you take this is actually boiling point, liquid vapor composition. It's a boiling point versus
Composition.
Boiling point versus composition graph. This need not be explained. Absolutely, the next 3 slides need not be explained at all. Because if they are clear with this concept, but some smart children will be asking, why ma'am it cannot be separated? Can you explain using graph? Sometimes, very rarely they ask. So for that, maybe I'll post the content of this. Maybe you use it as today post reading material and try to come back. But, for the ideal solutions, let me just explain maybe the ideal solutions. For the ideal solutions, the boiling point versus composition graph looks like this. The lower line is the liquid composition and the higher line is the vapor composition. So let us assume that let us assume that I am picking the concentration at point X. At point X. So when I move up, I see that it touches the liquid line here. Yes. Okay. The composition is composition A 100%, B 0, B 100%, A 0. So that similar composition only, like how we represent using the chi values in the previous.
Yes.
Only thing, instead of vapor pressure, it is boiling temperature. That's the only difference. So at point X, the composition of the liquid mixture is so much. At the same temperature. So temperature, I should know, that means I have a liquid mixture of component A and B, and I'm trying to increase the temperature, expecting any one to come up, any one's vapors to come up. Right. So I have reached this temperature, T. I have heated the mixture to this temperature. At this temperature, the vapor composition is this. Are you able to understand?
Yes, ma'am.
At the point, at the liquid composition X, right, I see that the liquid composition is so much, but the vapor composition at the same temperature is this. So at this temperature, this is the liquid composition, this is the vapor composition. So I boil the mixture of A and B, assuming that the more volatile component will come out. Okay. The vapor composition is closer to which component? Component
B.
B. So the vapor will be richer with component B. And the resulting liquid will become richer with component A, because you have removed the vapors of B. If you have removed the vapors of B, you are left out with more liquid A, no? So your composition moves to next point. The liquid composition moves left, the vapor composition moves right. Yes. So at this composition, when you are trying to do distillation, that means you would have increased the temperature to this point. At that point, the vapor composition is so much. That means the vapor is rich with component B and the liquid is rich in component A. And when we keep doing this, I finally get the pure A and the pure B in the vapor form.
Pure B in liquid and pure A in vapor, ma'am.
Pure liquid A on the left and the vapors of B to condense and collect. So I get B in the vapors and A in the liquid state.
Liquid.
I am able to separate them. But if there is a deviation,
Non-ideal.
yeah, non-ideal behavior. So what would happen now? This is the, we know that the graph is never a straight line. So it's always a curved line, right? So what do we see now? If this is the liquid composition with pink and the vapor composition with the black. So let me remove because it is boldly labeled. So at point X, let me try to do distillation. When I try to do distillation, the liquid is rich with A and the vapor is rich with what?
B.
B. Okay. So I am able to do separation. Okay, fine. Let us go to now this composition. Okay. Am I able to separate out? Let us see. Again, the same thing. The liquid is rich with A and the vapor is rich with B. At this point, the liquid is rich with A and the vapor is rich with B. What about this point? This is the point where
Both are
the same composition of the mixture in the liquid is same as the composition of
vapor.
the two components in the vapor. So am I able to separate the component B from component A?
No.
So the separation is possible until the point of azeotrope is reached.
That's C.
That's where you say ethanol can be purified to 95%. Not beyond that.
Yes.
Supposing we analyze the graph from the other direction, it is the same. This is the liquid composition. I will have liquid B,
B, vapor A.
vapor A. Liquid B,
Vapor
vapor,
A.
liquid B, vapor A.
Vapor
But
A.
at this point,
Both
I
are
will
same.
put it on the way. So I am no longer able to separate.
Yes, yes.
There is azeotrope. There is, after the achievement of azeotropy composition, the separation will not be possible.
Possible.
So these are the similar explanation is for this. I will try to post it in the group in
Yes, ma'am.
WhatsApp.
Yes, yes.
Maybe you can try to read. Colligative property. Okay, I think that I value problem alone. What I thought we will discuss about these. I value problem. Do we use these shortcuts, ma'am? These are not given in NCERT. Do we use this? I value, how it is related to N value and all? If
No,
not,
ma'am.
also no issues. Now, if not, supposing I've
No.
got A breaking down, say for example, I've got KCl breaking down as K plus Cl minus. Then I would say 1, 0, 0 in the initial stages. This is where I said this
Yes.
writing of the composition, no, 1 minus alpha, alpha, alpha.
Hmm.
So I, which is defined as what? Total number of moles of particles after association slash
Questioning of this dissociation.
after dissociation, I have 1 minus alpha plus alpha plus alpha.
Plus alpha.
But
So 1
before
minus.
dissociation, it is 1.
Hmm.
Yes. So do I get 1 minus alpha by 1 is equal to I?
Yes.
Yes. So can I now use this expression also? What is the expression 1 minus alpha? Just think of this. Alpha is equal to I minus 1 by N minus 1. What is N? N is the number of ions generated. How many are here?
0.
How many ions?
Alpha.
No, how many? KCl is capable of generating how
1,
many?
1.
ions?
1, 1.
Totally 2. So
2.
N becomes, so alpha is equal to I minus 1 by 2 minus 1.
1. Alpha is
which
equal
is
to I
again,
minus 1.
Alpha is equal to I minus 1.
Minus 1.
The same is the relationship. Alpha is equal to I minus 1.
Hmm.
Yes. So you are able to do this quickly. So for association, it is 1 by N. For dissociation, it is N. Okay. One more thing which I tell for these kind of questions, no, what I do, probably it will help you, is let us put it as del T observed. Del T observed is equal to K. If it is boiling for experiment, then it is KB. Then weight of the solute by molar mass of the solute into weight of the solvent expressed in kilograms. That's how the expression goes. LTP is equal to KB into M. If this is observed, then if you do not include the correction factor, this is also observed. No correction factor has been introduced.
Yes.
This is observed. This will give you observed result. If you substitute observed del T, you will get observed molar mass. On the other hand, if you take calculated value, no correction factor, then this will be MB
Calculated
into WE expressed in kilograms. So no correction factor so far. Observed will give observed result. You
calculated.
Calculated will give you calculated.
Okay.
The moment you introduce the I factor, AB, WB by MB calculated into WA in kilograms. If you are introducing I
factor, observed and calculated.
Even if you take calculated value, you will directly get the observed result. So this is very, very shortcut for doing such problems. If you have such a problem, 2 grams of benzoic acid is dissolved in 25 grams of benzene. Shows, so this is observed. There are many terms, shows, observed, experimental, these are similar terms. Calculated, theoretical, these are all similar terms.
Observed.
So you first demarcate, observe, okay, shown value, okay, experimental. Experimental is different from theoretical, is different from calculated, is different from expected.
Yes.
Expected
Yes,
is
ma'am.
different from experimental.
Mm.
So normally avoid using the EXP so that they won't get confused. So avoid using the term EXP. So observed is same as shown, theoretical is same as calculated. So if you have taken, even if you substitute the calculated molar mass, you have corrected it, you will be getting the observed colligative property.
Yes.
Or in other words, if you have taken a observed colligative property and you are trying to arrive at the correct molar mass, the correct molar mass can be achieved only by introducing the correction factor into it. So you can use these terms. So these questions can be later on, we know the I value, how they are.
Mm.
They are dependent on colligative properties or molar masses or number of particles. So these questions will anyway help either ask you to calculate the molar masses, then relate the I value, or
Mm.
do the colligative property analysis, then relate to I value, or directly I value.
I value can be.
Directly. So you have observed colligative property. You know the chemical identity of the benzoic acid, substitute, get the I value. So
Mm.
instead of going by the long route,
We
then
can
It's
use
always
Yeah.
convenient to directly apply the I equation.
Yes.
but in one of the examples in the textbook, the same example, I think. One of the association, this one only, yeah. In the same question, they would have found out the
Dimer.
molar mass. Molar mass that comes to 241. Then they would have said calculated molar mass is 122. Then they calculate I and then they go for the other percentage.
Calculation of MD.
Textbook, both examples they've solved that way. It's easier to go by this.
Mm. Yes, ma'am.
Direct method it is.
Yes.
Better to take this direct method.
Mm.